Hi Harshit, how is it going? Okay, so you are getting like the concepts of recursion linked list, right? Okay, makes sense. Makes sense. So like, the point is like, uh, hmm, obviously, that's one point. That is totally necessary. And okay, thank you for like saying this. I guess other student would be having the same feeling. I know that, but they are not saying. I don't know why. Okay, so we can have some more questions on it. Okay, that is one very good point, right? So um, I can what I can do is like I come to the class. Okay, I say okay, so we are going to solve. So we are going to do permutation using recursion. Okay, string permutation. So you'll say okay, okay, sir, let's do that. The point is, if I so that is what I do, right? I want input from you guys. Okay, so pick pen and paper. Okay, what I tell you, um, you need a base case. You need what should be the next recursive call. You guys tell me. I have not to tell you guys, okay, okay, this is the base case, this is the recursive call. Okay, this should be the parameter. It's your turn. Okay, Ki, sir, this would be there. And not only the class questions, I would suggest you guys like so is the lecture questions completed, Harshit? But okay, that's good. But why not like why not you guys like contact with me, right? You do not have to be in the class itself. You can just DM me if you want. Okay. Mm-hmm. Okay, makes sense. So uh okay. Okay, so what I can do for this is like you guys can tell me, sir, this question I'm not getting. Okay, so any of like Harshit can say, others can say, okay, sir, please let's discuss this question. Mithun can say, okay, so let's discuss this question, this type of question that I'm not understanding permutation of a string. So we can initiate with that and we can see how it works. That can be one thing. Okay, and we can proceed with that part. But okay, it's all good and fine. I will just share the screen and then I guess we can continue with our topic. And recursion is here also, so welcome back to recursion in linked list. Okay, let's see this out here again. But first of all, let's cover some more concepts and try basic linked list. Let me check on my phone if we have enough data to continue. Otherwise, okay. And let me also drop a message in the group that we have started. Okay, let's see. Okay, so what about you guys? Others, Meton, like how is it going? Are you facing any doubts, issues? All good till now? Okay. Mm-hmm. Recursion 3. Okay. So what are the questions in that? Oh, okay. That is some very good questions, right? Okay. That is interesting. We can discuss that. So that is what I want to like. Why I have to ask from you guys? You could have told like, sir, this is not. I'm not getting the point. Okay. Anyways, oh, I see. Okay, okay, makes sense. Okay, So okay, that's good. So let's do this part. Let's start with this linked list part, and then in the end we can solve the keypad question. Okay. So let's get started. So with the node, coming back to the linked list. Okay. Array list we are clear with, right? Yesterday. So here is a picture for you guys. Text picture. Okay. Please try to understand. This is an element. This is address. Okay. ADD. Okay, that's it. I will not write anything else apart from this. Uh, so what we did, we said that let's say we don't have continuous space on our machine. So I say store the element in a place, and that element will store the address of next element. This is what we agreed on, right? Okay, so something like this, something this sort of a structure. I'm not saying this is how it looks, but yeah, let's say that linked list is storing integer, a long chain of that. So you go to first house, one lives here and one will say okay, two lives here, two will say three lives here, and four lives here, so on. So it doesn't matter. So until unless you have a space in your on your RAM, you can use this, utilize that space, so no issues for size. That's one point. Okay, now how do we do it programmatically? How do we implement this programmatically? Okay, let's see this also. Also, we discussed that class is a template blueprint of, we can say, any real world entity. For example, we talked about fridge yesterday, data members, member functions, data members holding the values, the properties of your like real world entity. Some functions, for example, if you are creating a class for fridge, so fridge would be having increased temperature, decreased temperature, like setting the mode and all those kind of things. Similarly, you can have your own blueprint, okay, of any data storage. Now this type of data structure does not already exist in memory. Sorry, this type of data structure do not already exist in Java. So you have to create your own custom data type kind of thing. Okay, your own custom objects. Just as you have string integers, you have to create your own custom data storage method. Okay, so we are going to do the same thing over here. Okay, so this is neither a string nor integer. Okay, so you cannot store in something. You cannot say integer equals to 1 comma add. Integer will complain, what is this? Okay, so we are going to do that. Yes, yes, very nice. Yes, this is a user defined data structure, and here comes the data. Okay, so what are the two things we require here, guys? The data and the and correct, very correct, very correct. Okay, data and the like the node. Now this class has something called as constructor. Okay, just for what you can say, just for as a starter, know that constructor will initialize your current value. Okay, data has no value, next has no value, so it is just to initialize the current value. Okay, what is this? Just data. What is this? Let's see this. So how you write an array? Let's see that part. Int equals to new int 20, 30, whatever you want. Something like this, right? Now whenever you say new, okay, what happens? So why do we use new? Any ideas? Anyone wants to try? New. What is new? We already have used in arrays, right? Obviously, we have used that. Okay. Next question for you guys. Let's leave this question. Next question. How many of you know about heap memory in Java? What is a heap memory? Okay, so give me a minute, guys. Let me check if I can connect my pencil with my laptop. Then I can just draw some diagrams. Give me a second. Okay, so I have connected with my pencil. Let's see. Let me try to draw something. I will open the Jamboard. Okay, so let me draw. Okay, so here I get the pencil. So this is something like this. There is a structure which is followed. This is a stack. Okay, this is stack. We'll discuss. Okay, don't worry. Whenever your program is under execution, ठीक है, जब भी program execution में होता है, there's something called as stack. ठीक है. Now this has also a global part. Okay, globals and constants. Globals and constants. So whatever the global variables, constant variables are there, they exist at a memory. Okay, they exist at a different memory. Next, we have something called as stack. We use this stack in recursion. Okay, we told that whatever the calls are there, either in pending state or in running state, has to be loaded into the stack. Guys, you remember this part? Okay, so let's say that your current function is running function one, so it is in stack. Function one, it is in stack till it runs. Once it has completed or returned, it will be popped out of stack. So this is stack memory. This is stack memory. There is a global constant memory. Okay, there is a code memory where your code is loaded. Your code means your current code, whatever you have written. Okay, so there is a code memory, global and constant memory. So here is code. Everything is loaded into your RAM. Why RAM, not in the hard disk? Any guesses? Okay, it is faster than hard disk. Yes, read write is speed is faster, right? Okay, so that is why RAM is cost like it has more cost than your hard disk, right? Okay, and cache is more costly, and processor is costly as okay, like has the highest cost because of their read write operations speed. Okay, coming to this point. Now, whenever you say new, whenever you use the new keyword, okay, int r equals to new int, something this sort of. Okay, so you say your memory, sorry, you say your program to allocate something in the heap memory. Okay, allocate something in the heap memory, allocate some storage into the heap memory. Okay, let's say that 20 bits or whatever be the space you want. Okay, and the address is stored in the somewhere in the stack. Okay, the address, the base address of your we already discussed about the base address of array last day, right? The base address where your array starts, right? Okay, and rest is there, so rest the address is there. The same in the same fashion, in same fashion we are going to do this for our application. And probably if you go to some of the code in over here, So where is recursion 3? You guys are talking about recursion. So where is recursion 3? So it was here, I guess. Okay, but anyways, we can open anything. So let me open the main code. Okay, you see this new is also used here. Okay, so why is new used here? We are going to talk about this part only. So new means allocating some space in your heap memory, and so heap is larger memory. Okay, so you see the diagram. So heap is a larger set of memory allocated, and stack is separate. Okay, but all of them are already in RAM, so don't. So this is logical separation of your memory. Okay, like physical separation नहीं है. Coming back to the point, you have created this class and this. Every template. So how many nodes we have to create? How many data we have? So okay, so the number of data we have, we can create as number of nodes we want. So how do we create a variable of our custom data structure which we have created? The process is node. Anyone wants to say like how do we do that? How can I create one? Okay, you guys agree with the syntax? Isn't it the same thing we did with array also? Okay, assigning a node. Let's try something. So now node 1 is not a simple data structure. It has something the data part is already there. So anyways, it doesn't matter. You can anyways assign it, but let's not do that right now. Let's just print ln node 1 dot data plus node 1 dot next. So it says 20 and null. Okay, means since only we are initializing, only initialization part is my data part. So 20 is assigned to data, and next is null. So null is a data type in Java. So if anything is not there for, so okay, there are two types of data types. What are the two types of data types, guys? Very good. And what are the types of primitive data types? Correct. Correct. Very correct. String. Do you guys agree? String is primitive. Okay, so what is a string in Java? Before we move to the answer, what is a string in Java? And obviously, very correct. Guys, we are getting, yep, yep. Hmm. Non-primitive, okay. Like, but thank you for trying, guys. I really appreciate that. String, though a string is non-primitive in Java, okay. Not to confuse you guys, like I also for several months believed that a string is a primitive data types. So no need to like feel that you guys like are wrong, like it's totally fine. I so but I realized later that a string is a non-primitive data types. Okay, non-primitive means they have some different kinds of implementation. They have their own member functions. So someone asks what is non-primitive, so they have their own kind of, they have their own set of method functions. They have their own kind of initialization function. They have objects. You can, so basically you can create objects of their type. That is what non-primitive is. Primitive, just primitive is store the data. That's it. This is the difference. Okay. Guys, is this clear? String arrays classes. Okay. I'll take that as a yes. Okay. Write it down. Try it out. Okay. So there is a small string also. Okay. Wait a minute. This is not Java. What is this? This is JavaScript, right? Yeah, this is JavaScript. Okay. Please don't confuse yourself. This is talking about Java. Okay. Coming back to our point. Now, let's see that. Let's create one more. Okay. Now, what is this here? What is this here? Someone wants to try? What is this? What is this? Any guesses? Very correct. Yes. Gone. You want to add something? Very correct. Very correct. Yep. Yes. Yes. Obviously. So guys, this points to the current object. ठीक है? जो भी object आप यहाँ पे बना रहे हो, like that is what this points to. This data and this parameter is the same thing. ठीक है? But this data and this data are the same thing. It means that this belongs to, this points to the new object. वो नए object के बारे में बात करते हैं. Okay. There is something class which is separate. There is something object which is separate. Okay. So there is something called as classes, and there is something called as object. Classes are just template. Okay. They are not anything without a object. ठीक है, वो ऑब्जेक्ट के बिना जस्ट अ नॉर्मल टेम्पलेट और अ स्ट्रक्चर, दैट इज इट. ठीक है, और कुछ नहीं. what adds value to it is the object. ठीक है, so like node object is here. ठीक है, one answer is node object. Okay, so node 1, node 2. So how can I link these two nodes? Mm-hmm. Okay, so very correct. So I can write node 1 dot, not here exactly, node 1 dot next equals to node 2. Okay. How many of you are getting this line and how many of you are not getting this line? Please ask right now. How many of you are getting this line number 33? Any doubts on this line? Please ask. Okay, I will take that as a no. Okay, I guess you guys are getting at. Okay, so we printed 20 and null previously. 20 and null was there. What should be next? What should be next? Let's see that. Now what it prints? 20 and null. It prints 20 node at the rate 67732. Isn't it what is this? What is this exactly, guys? Very correct. Address of your custom data by, yes. And this is in which format? Which number format? Very correct. Hexadecimal format. Okay, that is the point. So storing the address. Okay, and yeah, I guess you guys are probably getting the implementation. So that is well and good. how to traverse over this. Okay, so before traversing, let me make a uh, bigger list. Okay, bigger list. Okay, we'll make some function so that we do not do this manually. Okay, we'll create a function for this. We have already created we have already created data members. It times for us to create member functions. Now, see, we haven't read object oriented programming, but we are already inside object oriented program. We have already talked about classes. We have implemented the class. We have already talked about object. We have implemented the object. We have talked about constructor, implemented constructor. Okay, so just be with the class. Let's see what we learn next. Node 1, node 2, node 3, node 4. Okay, node 2 dot next, node 3, node 3 dot next, node 4. Yeah, this is the part. And what I will do is I will say for so for any data structure to work, what we need, guys, we need insertion, we need deletion, we need search, traversal. Okay, insertion, deletion, search. Okay, so these are the things we read, right? Read, write, and delete operation, update operations. Okay, so these are the four operations for any data structure is required. Okay, the same as database. What is database? What is a database, guys? Any type of answer would be expected. You can just say in very correct, very correct. So one way, table forms. Although nowadays we have different ways also, apart from table. NoSQL databases, which you guys are probably going to learn after in 1 or 2 months. Okay. Okay. Anyways, so let's come back over here. So, not for loop. Let's take while loop. Okay. Now I will say node current is equals to node one. Okay. What is this, guys? Did I create a new node here? What I did? Very correct. Very correct. Now I will use the same to check if we are at the end of our list. Okay, what do I mean by this line, guys? What this condition means to you guys? Okay, okay. What? Mm-hmm. Mm-hmm. Okay, okay. Mm-hmm. Okay. Very correct. Very correct. What about the other guys? Like you guys are getting the point? Okay. Okay. So I will say current. Now I have to jump on the next. So what should I write? Very correct. Right. So this is one point. Now, what comes over here is let's pick this. This is very helpful. So just copy pasting whenever possible. Copy paste. So node one dot data. No, node one not it. Current dot data. Okay. So okay. So this is like the insertion part. Now this is the traversal part. So we have 20, 10, 10. 20, 10, 10. And what else, guys? 20, 10, 10. 20, 10, 10. So node 1, node 2, node 2, node next, node 3, node 3 dot next, node 4. Wait a minute. We do have 4 nodes, right? It is printing 3 nodes. So what's the correction here? Very correct. Very correct. So that is the thing. Okay. Visualization. So we'll just see one. Okay. So I will draw this iteration once. What happened exactly? 20, 10, 10. Okay. So 20, 10, 10, 10. Okay. Let's come here and picturize what is happening exactly. Now, here is our heap memory. Here is my heap memory. Okay. Let's make a bigger picture of it. This is node 1, this is node 2, node 3, and node 4. Okay. Node 1 has the address of node 2. Node 2 has the address, sorry, node 2 has the address of node 3. Node 3 has the address of node 4. And while traversing, so the data part is here, the next part is this. Next part is address of this. Okay, then it is over here, and this next part is this, and next part is null for this node. So it looks something like 1, 2, 3, and 4, and this is pointing to null. This node has a special name. What is that? Very correct. We call this as head node. This also has a special name. Very correct. Coming back to the point. So this is what we did for traversal. Dot next, dot next, dot next, dot next null, and that's it. This is how it looks when you do new node 1 equals to new node 20. Allocate a space in heap, allocate a space in heap, allocate a space in heap, allocate a space in. That is it. All now the address I only need exactly to be stored in my stack is the head. Okay, that's the only thing I want. Okay, not anything else. So let's say that there are n nodes. Okay, let's say that there are n nodes. So where is the code? Let's say that there are n nodes. What is the time complexity of this loop? Very correct. So one thing is for sure that traversal is same as array. Okay, order of n. Uh, guys, do you agree with that? Okay, we agree with that. Okay, so traversal is same. Array traverse करने में भी order of n ही लगता है, and so same cases here. Don't worry, we'll talk about some other couple of points, not about just iteration. There are a couple of. Give me a sec, guys. I dropped tea on my hands. So give me a minute. Let me wipe it off. The point is, one is traversal, one is addition. So addition at the addition at the tail, like at the back point, is order of. Very correct. Yeah. It's correct. It's correct. You see, you see line number 36, 37, and 38. We have to always keep track of the last added node, right? If it is node 1, node 2, or node 3, so we have to keep track of which is the last node, right? Now suppose we have been given only pointer to head, okay, like we have in our loop position. What if you already so you only know the address of head? To insert a node at the tail, you have to do order of n. Okay, so you have to do order of n operation. Okay, the same is for deletion also. To delete in linked list. Now, how do you insert a new node at the end? Let's take the help of this loop. You have to, and you are given only the head. Okay, just the head is with you. You have to insert at the end of the linked list. What to do? Okay, okay. So we'll traverse to the end and we'll add this. So not going to print this. Insertion at the end. Insertion at the end with head node given. Okay. So current dot next is equals to new node, new node. Okay. Let's say 30. Okay. And since okay, so by this traversal operation, by this traverse, I will comment this part so that because the current will reach at end and it will give me error. So current is pointing to node 1 and current is going till the end and I'm adding the last node to this. Okay, so current is pointing to node 1. This is my loop while current not equals to null, current equals to current dot next. Finally, when current reaches to the end, I do current dot next equals to new node 30. Are you getting this insertion logic, guys? All of you are getting this point. Now here comes the second question. How many of you are saying, sir, this is wrong? This will throw error. It is throwing error. The error is null pointer exception. Now take a minute. What's the error? Or maybe 2 3 seconds. Mm, Very correct. Very correct. Current dot next equals to not null. The check was current not equals to null. If current will reach to null, it is already out of the linked list. How will it will add it at the end? So you have to be at the tail, means at the last index. Sorry, last node. Then only you can add a new node. Make sense, guys? Okay. Now it is correct. Traversal is done. Insertion is done. Insertion is order of where n is very correct. Okay. The same as with deletion also. Okay. Here's the point. I want to delete. Okay, let me change the data over here. Now the question will be solved by you guys. You have to give the answer. Now it's your turn. So the linked list would be 20, 10, 40, 20, 10, 40, 50, and 30. Okay. Now I will reset this pointer to head. Okay, I'll reset this pointer to head. Okay. I want to delete a node with value 50. With value 50, what should be my code or the logic? Hmm. Okay. And how will do that? Take a minute. Take a minute. Write on a sheet of paper if you want, or a notepad on your system. Guys, I need input from all other guys too. Okay. And we have only six of you here. I don't know, like, what's the issue, guys? Okay. Anyways, try. Okay. Okay. Here's the point. While let's say that key value is 50. I want to delete 50. The question is 50. I'll say current dot data not equals to 50, and the assumption is there is no repetition in the linked list. ठीक है, assumption ये है कि linked list में कोई repetition नहीं है, मतलब कि 50 is present only once. Okay. Okay, here's the point. Current dot data not equals to 50. Okay. And for the traversal, current dot next is equals not okay. So current equals to current dot next. Current equals to current dot next. Okay. Hmm. Okay. So current data node equals to 50. Current equals to current dot next. Now my current will stop at which node? So it will stop at 50, right? Okay. When will this loop terminate? So where will be my pointer? Hmm. So this loop will terminate when current is at very correct. Are you getting the point, guys? Understand the condition. Okay. Now this will not work. So what should be the condition here? The condition will be current dot next dot data not equals to 50. How many of you agree with this condition? Now, very correct. Very correct. All of you agree with this point, guys. Guys, current dot next dot data is 50. So current dot data not equals to 50 will stop at when node reaches 50. Now I'm saying current dot next means, let's say current is 40. So 40 dot next, which is 50, 50 dot data 50. not equals to 50, loop will terminate at 40 when current is as 40. Make sense, guys? Okay. Now, how can I delete the node? Current dot next means 50, but I will say current dot dot next. How many of you agree with this solution? Okay. So, and I will say system. How do we check it? So system dot out dot print ln current dot next dot data. So we'll find the current is as 40, so we'll find what's the next node of it. And let's run this part. Okay, so after 40, and obviously we have, let's print this also, current dot data. Okay, so current dot data. Okay, and if I don't write this line, let's see then also. It was 40/30, right? 40/50. Okay. Okay, so just a graphical representation and we are good to go. Where is the file? So what we did exactly is, so we had, okay, so we had 10, 20, 40, 50, and at the end 30. Now I said, when current, okay, so this is current dot next is this, current dot next dot data not equals to 50. Okay, my loop will stop. So current, and this is current dot next. Okay, so my loop will stop at this point, current is pointing to 40. I want to delete this node. Okay, now I cannot directly delete it. What I can do exactly is, I will say 40 dot next, 40 dot or current dot next is equals to current dot next, which is this dot next. So current dot next, and what is this? Current dot next. So current dot next, okay, equals to current dot next, means fetch this address, cut this address, and point to this address. Now my list is 10, 40, not 50, not 50. It will be 30. You'll say, sir, 50 is connected to 30. But will I ever reach this node? Okay. So what will happen with this node? It will be garbage collected by Java. How many of you know about garbage collection in Java? Okay. So in order to keep the memory management, like in order to keep memories, okay, efficient use of memory, we have garbage collection in Java, which will Remove all the unreachable nodes. So this 50 is unreachable. We cannot reach at 50. We cannot reach that. Okay. So this is how we use for deleting. Guys, is the delete part clear, guys? Okay. So what have we done till now? Deletion. No. Okay. Class, object, addition, linking, uh, traversal, deletion, updation. You guys can do updation now. Okay. Based on key, guys, you can update the data also, right? Okay. And okay, what is the time complexity of updation? Same as traversal, same as deletion, order of n, right? Okay. What is the updation, like what is the time complexity of updation in array? Okay, in array. Yes, it's order of one. You can directly reach to a cell, right? Yes, yes. Guys, all of you are getting the point. What we are talking about data structures. Okay, they have different properties, different data structure, different properties, different functionalities, different advantages, different disadvantages, and so on. You cannot say advantage, disadvantage. What we can say that use cases, maybe a good word. Okay. Anyways, so this is the point. Um. Okay. So there are a couple of other things we can discuss around this, like, but let's see if we have questions. And guys, I got to know like we need to do some more recursion problems, especially recursion 3. Okay, to be point, and we'll probably be having our classes early this week. Let's see if I get time on Saturday, Sunday, we'll do that on Saturday, Sunday. Otherwise, maybe I will. Okay, no worries. I will schedule it late night, like around 9 to 10 or something. So you guys are like done with your job. I guess that would be appropriate. Like you can. Okay. Yep. And I also get free at that time itself. Yeah, so we indeed have lecture 3 over here. Anyways, the point is where is linked list? Guys, can you do this question, guys? Length of linked list? Okay. Print ith node, insert node in linked list, delete. We have already done like it means that you guys are getting like a conceptual clarity for this, right? Oh, okay. Yeah, obviously. That should be the what you can say, the conceptual mindset, right? And if recursion, if someone learns recursion, everything is easy. Okay, you'll find out why I always talk about recursion, and maybe you have found it anyways. So like every data is a recursion. That's recursion. Backtracking, recursion, and that's it. Palindrome linked list. Palindrome linked list. You have given a head a singly linked list. Singly, what we did right now is a singly linked list. What is a doubly linked list? Let's talk about doubly linked list. Anyone wants to try? What's a doubly linked list? Singly linked list, which you have already learned. Okay, what is a doubly linked list? Next, very correct. Next, previous, next, previous, next, previous. Okay, so you can proceed both the sides. Okay, what is circular linked list? Mm-hmm. Okay. Mm-hmm. Head points to the first, and that is it. Okay. Doubly circular linked list. Combination of both of them. Okay. Pardon my drawing. Okay. Here it is. Type of linked list. Okay. Hmm. Okay. So palindrome linked list. Write a function to check whether the list given is a palindrome or not. Okay. So a linked list is given, and you have to tell if it is palindrome or not a palindrome. Okay. You are given a head, and it's a single linked list. Oh, okay. Let's see this question, and I guess we are done for the day. Next, we can continue next session. So, palindrome linked list. Hmm. Okay. How does it work? How to tell if it is a palindrome or not? You already know all the things which is required for this question. We already are. We already know that. Yes. Nothing else we need to know for this question now. So traversing from the head dot next, head dot next, and maybe reaching at the mid. Okay, so reaching at the mid. Okay, so mid or mid plus one. So, so what you can do? Have a head pointer at 10. Okay, so take two pointers. Have a pointer at um, let's say, okay, will that work? Or what we can do? Hmm. Guys, are you trying? Mm-hmm. Mm-hmm. Okay. Mm-hmm. Okay. Mm-hmm. Mm-hmm. Okay. Okay. Array approach is also correct. Okay. Mm-hmm. But there's a disadvantage, not disadvantage. Really sorry for that. Uh, There's a space complexity with that. Uh, okay. 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 L- yes. Yes. So how do we reverse it? Okay. Here is a homework for you guys. I will tell you the reverse logic. Okay. Please try it out. Please try it out. I will tell you how. So let's take two nodes and try to reverse it. 30 dot next 20. Here is current dot next points to 20 and 20 points to null. Now how can we reverse it? hmm Take a previous pointer equals to null. Okay, go on. hmm hmm Okay, so next will be hmm hmm so one at one. So taking three references, one current to the head, next to the head not next, previous to null. First step would be current dot next equals to next. Okay, sorry, next dot next should be the current. Or can we do something like this or not? Let's try this one. So we have current, right? Can I say that for these only two nodes? Okay, later we'll do it later. Only for these two nodes. Current dot next, C dot next, current dot next is equals to current dot next, current dot next. This one dot next, which will be dot next equals to current. Okay, and current dot next equals to null. So current dot next equals to null. The only thing we require here is now current is pointing to this. Now I have to point my current dot next equals to, sorry, I have to point my current to current dot next. So this will come here. So current dot next is null. So have I reversed it with three steps? Guys, are we clear with this? Current dot next means current dot next 20, 20 dot next again points to 30. First step. Current dot next, which is 30, will become null, means current. So the previous current will be pointing to null now, and 20 is pointing to 30. Now, still the current is pointing to 30, which is not correct. So we have to update current to current. Okay. Here's a situation, guys. We ran into a situation. I cannot write this step, right? Current dot next is null. I cannot write this. So we have to have one more pointer, which others was mentioning. We have to have another pointer. Let's say next pointer. which when we are making this current dot next null, before this step I have to do next is equals to current dot next. Finally, first step, second step, third step, or the fourth step would be current is equals to next. First step, second step, third step, fourth step. Please reiterate the steps and tell me if this is correct or not. Are you guys getting the point? I'll share this with you. I can share now also. Try it out and let's meet in the next session, guys. Till then, best of luck. And before going, please mark your attendance. Where is the sheet? Where's the sheet? Where is it? Where is it? Feb 22. Here we are. Okay. And let me write insert a column to the right. Today's 22nd Sunday. Please bookmark the sheet if you haven't done it already. And here goes the sheet. Okay, guys. Thank you so much. I hope you guys are enjoying. Bye, guys.